In this video, I want to do this problem, which is involving constant acceleration. So let's read it. This guy, Horton Hoover, is speeding down the road in his new red truck. He sees a child fall off his bike, so he hits his brakes and skids to a stop at a rate of -7 meters per second squared. If it takes 5.25 seconds to stop, what was his original speed? All right, I'm going to use the guess method to solve this problem, just like you will a lot of other problems. So my G is about givens. What am I given in the problem? So I'm going to look through here, and the first number that I come to is -7, and meters per second squared tells me that that is an acceleration. Meters per second squared are the units we use for acceleration. And if it gives you the number in negative, you better keep the negative in the problem. Okay. And that makes sense because if he's moving in a positive direction and he skids to a stop, he must have a negative acceleration in order to do that. In other words, he's moving in this direction and the rope has to pull in this direction in order to stop him, to get him to slow down. All right, so that's acceleration. What else are we given? Well, it looks like 5.25 seconds, and that's a time. So my time is 5.25 seconds. Doesn't look like I have any other numbers. Well, I might look and see, okay, well, what am I looking for? Well, the question is, what is his original speed? That's another way of saying what's the initial velocity. That's what I'm looking for here. Still don't have one number, okay, because I only have 3 variables. The acceleration equation has 4 variables in it. I'm still looking for one, and if we read closer, Horton hits his brakes and skids to a stop. So this is actually telling you that the final velocity, not in numbers, but the final velocity is 0 if we're skidding to a stop. Starting at whatever we find here, and we're coming to 0. So those are all my givens. I'm going to look and make sure that all my units are correct, and if they're not, I'm going to convert. And everything is correct here. No conversions to make. Hint, hint, if you're doing this problem, you got a conversion to make. The equation here, we're looking for VI, the initial velocity. I'm going to choose to use this equation. You don't have to. You can use our other one that's A equals VF minus VI divided by the time. You can use that. It's maybe a little bit tougher for you to do in terms of algebra, but you'll get the same answer if you do the algebra correctly. I'm going to choose to use this one. First substitution. Final velocity is 0. Initial velocity is what I want to know. The acceleration is negative. I want to put the negative in here. The time is 5.25 seconds. Final S is to solve this problem. To do that, I've got to multiply 0.7 and 5.25. I might just go ahead and rewrite this up here. VI plus -7 times 5.25. 0.7 times 5.25 is 36.75. And it's negative because we have our negative here. And I want to isolate VI. To do that, I have to get rid of this number and I have to do the opposite operation that's here. This is a negative number. Since it's a negative, we're going to add it. We also could have, instead of plus and negative, we could have just made this a minus and left this alone. I just chose to put it this way. Add 36.75 to both sides. Not subtract, add 36.75 equals VI. That's what we're left with. And the last thing I want to know is, what are my units? It's got to be meters per second. So our initial velocity was 36.75 meters per second.